Good afternoon, and a very warm welcome to this May 2022 event of the Royal Statistical Society's Special Interest Group for Finance and Economics. It's titled Gingado, Machine Learning Library Focused on Economics and Finance. My name is Ryan Defina, joining you from Switzerland, and I'll be chairing the session this afternoon. So we'll start with some housekeeping. Firstly, we'd of course like everyone to please keep yourself muted throughout, for courtesy to others participating. If you'd like to ask a question, we would encourage you to do so via the chat function. This offers the speaker the opportunity to address questions on the spot if appropriate, or to wait until the end. So we're intending to leave approximately 15 minutes at the end for questions. And there I'll collate all questions received and open up the floor further to participants. Okay, so now, of course, to the star of the show, the speaker. So I have the pleasure of introducing Doug Araujo. Doug joined the Bank for International Settlements in September 2018, where he's been an economist in their international data hub since May 2022. Previously, Doug was in the Secretariat of the Basel Committee on Banking Supervision, overseeing a range of policy and supervisory topics. Doug also worked on financial stability monitoring as a fellow at the Financial Stability Institute in 2014. Before that, he worked at the Central Bank of Brazil on macro-prudential supervision and led efforts to develop and implement the Brazilian proportionality framework for prudential regulation. He's also supported a number of jurisdictions in enhancing their macro-prudential frameworks as a member of International Monetary Fund missions. And before this, Doug worked in the private sector in Brazilian financial markets. His current research focuses on banking and the effects of digitization on finance. And of course, Doug also contributes open source software at the intersection of machine learning and economics. The latter, of course, being the focus of his talk this afternoon. So a big thank you, Doug, for taking the time to do this. Really appreciate it. I'm really looking forward to what you have to say today. And so I'll turn the floor to you.
Well, thanks very much, Ryan. It was a very kind introduction. And thanks also to Gia, who's been supporting this event. And thank you all for your attention and your participation today. It's a huge pleasure for me and an honor as well to be talking here at the Royal Statistical Society Special Interest Group meeting in Economics and Finance. So thank you all in advance for being here today. As Ryan anticipated, the topic that I'll be presenting to you today is this work I've been conducting recently, and it's called Gingado, and it's a machine learning library focused on supporting the use of machine learning in use cases related to mainly economics and finance. And before I begin, I'd just like to highlight that the usual disclaimer applies here as well, that all of my views here with the content, they're all mine and they don't necessarily reflect those of the Bank for International Settlements where I work. Okay, so just to give you all a flavor of the things I'll be presenting, Gingado is a library whose goal is to facilitate, to offer convenience to users who are working in machine learning in the fields of economic and finance, while at the same time promoting sound modeling practices or good practices overall related to machine learning. The main contributions that Gingado seeks to offer first is to facilitate data augmentation using specifically data from official sources like statistical agencies, central banks, international organizations, but in a way that is relevant to the particular use case at hand. The second one is to offer users the possibility of having automatic benchmarks. Those are models that they are benchmarks to help the modeling process and ensure that users can really tell when they're making an advance in their model process that is beyond what is just a reasonable low-hanging fruit here. And the third leg is to support and facilitate model documentation as part of the normal workflow in machine learning and economics. So, and try to embed this as part of the usual process of the daily process of working with machine learning. And I hope it comes across throughout my presentation, but I just wanted to be explicit that when I am developing Gingado, the things that are on my mind, the principles that I follow in the design are three. So first, flexibility. I want Gingado to offer users flexibility to either use routines and processes just out of the box, and it works, while at the same time offering the possibility for users to really go deep and construct customized methods and objects, or really tweak all parameters as users see fit. The second principle is compatibility with widely used machine learning libraries, so that using Gado is really just as easy to incorporate to any existing workflow. And also, of course, when you find some problem, you'll find extensive documentation in the base library online and support forums. So there's already a community of people using those widely used machine learning libraries, and I wanted Gingado to build on top of that and not be a constraint. The third principle is responsibility. The fact that machine learning models, they can, depending on the use case, they can really be so scalable and so fast and impactful that really I personally believe that including model documentation, but also including as part of that some ethical considerations should be part of modeling process overall. So Gingado should help at least bring a small contribution towards more responsible machine learning. And why is that? When we think about the context that we're in, so this economics, finance, statistical world, we see more and more academic use cases in using machine learning. So, for example, if you quickly scan the last years, for example, just the journals, the journals that are considered to be more central to the economics debate, for example, we see that more and more we have papers that are using machine learning sometimes to help build the data set of interest and for that particular research, sometimes to help estimate the models because they tend to be, in some cases, multidimensional, and in some cases, even as subjects of study themselves. So I cited here some references, but they're far from exhaustive, and there's a growing literature using machine learning overall. In addition to this, we have not only the academic world, but also practitioners that are increasingly deploying machine learning models. So we have, for example, lenders, both more traditional brick and mortar banks, but also fintech lenders using machine learning algorithms to help screen all applicants, to uncover what could be suspicious money laundering transactions, to help forecast prices. For example, if they have a trading desk and they want to extract some alpha from the market, so they might deploy models for those purposes as well. So there's a huge variety of cases. I just mentioned a few that I think are more intuitive to think about, and even if a person is not an expert in that area. And if we look across machine learning, similar to other industries, their specific use, it encompasses a wide range of tasks, including classification, regression, clustering, forecasting, and many other tasks. So not only they're being used to drive economic thought in academia, but also economic practice. They're being used in several different areas and ways. So this is the increasing use of machine learning. But the thing is that even with this increase, it's happening even though actually using machine learning presents a number of operational roadblocks. I think when you actually go down from the concept to the code, it is cumbersome to try and set up those models. And not only cumbersome, it could be even error prone. So some of the challenges here that I face when I'm working with machine learning, those in economics, for example, those are sort of my main pain points. So first, we have an increasing availability of data from reliable official sources, from many other sources as well, but it's operationally tricky to set up ways in which you can pull data from all of these different sources in a consistent way with concepts that are comparable, or at least where the lack of comparability of the concepts is transparent to you. In addition to this, making sure that when you run the model once, so you get all the data, make sure it's consistent, but then being able to have the same model remain consistent with its data collection over time as you use it, for example, in production, it can get complicated very quickly. But at the same time, even as we have more data, and even if you overcome all of those challenges, it's not necessarily guaranteed that more data will improve your model. Machine learning models, they tend to respond well to more data, but there's a number of reasons why just blindly adding all of the information that you have might not be optimal. So I think one of them could be, for example, that, well, for starters, model complexity increases a lot when you just blindly add more data, and that could get tricky also in terms of explainability. But there's also another constraint, which is computing time and even the operation difficulty of ensuring that all of the data is consistent. So more and more data blindly added to your model, to your data set, might not be the best outcome. So while there isn't a way to get all the data you want in a comparable and reliable way, there is currently also not a way to make sure that this data that you're adding, they're actually doing good for your model. Another pain point is that when you're go from the traditional economics setup and the traditional way that economists learn to actually deploy econometrics tools and econometric software, statistical software, there's still a bridge to be taken from that point up to the point where economists, they're comfortable sitting in a machine and start building a machine learning model from scratch. So while I believe most people they're comfortable, taking their data set and transforming their economic thoughts and insights into formulas or regressions that they can estimate, it's far from guaranteed that this is done in a way that is satisfactory for machine learning cases. And not to mention that because of normal specialization constraints, I don't think there are many economists that are well versed in even basic software engineering good practices. So it could be, for example, that especially when you work in teams, you have co-authors, you have other people, research assistants, everyone working the same code. So it's it could get easy to create all of those opportunities that the current way of modeling bring in terms of being error prone, of using the wrong data, and leading to, for example, you using data you're supposed to have hold out from the model, using in the trainer model. So all of that is just compounded. And not to mention that when we take a step back away from economics and just look across machine learning use in all industries, we had a huge pickup in the last 10 years. In particular, starting 2012, there was a huge movement to use machine learning in several fields. So, for example, computer vision, even search engines. It's even hard to remember what it was like when search engines didn't use machine learning so extensively. So there, language processing. So there's a lot of other fields that this huge pickup in machine learning happened before economics. And one observation I had is that the use came first and the ethical considerations came later. So all of those fields, they had some pickup to do with respect to, now that they had all of their business models based in machine learning, how do they incorporate ethical decisions, and how do they document well for a variety of stakeholders the models that they're actually using. And I believe that the strides they have made are really impressive if we consider that they really did 10 years in development in this area in a short amount of time. My observation and my proposal is that economics, since we are only now increasing, so ramping up the use of machine learning in various setups, I hope that this library can contribute at least a little bit to make sure that economists think about not only model documentation, so communicating the model for other stakeholders or their future selves, but also in a way that this could incorporate ethical decisions too. So let me run through some stylized workflow of what using machine learning economics would look like. So just to help highlight some of those issues that I've raised before. So for example, say that I want to predict the foreign exchange rate for tomorrow or for the following day. So thanks for the question, Bruno. I'll take that shortly when I talk about data augmentation, but please keep on coming in. So suppose I want to build a model to forecast foreign exchange rates. So I will obtain the data sets of interest, and this will be a variety of different sources. So I will have most usually different specific functions, each catering to different API, meaning the interface that each source offers to users to get the data. I will then proceed with some feature engineering for those that are not too familiar with machine learning. That essentially means wrangling the data in ways that they might be, the model might perform best. So I might interact features. I might do all sorts of transformations to them, including some nonlinear transformations to try and offer the model, the algorithm, the best possible set of data that they will be looking at to perform well. Then I would be adding more data, so other market variables. Let's say in addition to the leg of the interest rates, I also want to add interest rates, stock prices, commodity prices, whatever. I'll then create a benchmark model, which would usually, in most cases, not most, but in many cases, this would be even simplified, like basic building blocks, time series models like ARIMA. It could be even another model or just a linear model as well. And then I would try and create an additional model, so candidate models, evaluate them compared to the benchmark, and then hopefully everything working out well, I will document the model. So make sure that some form of communication, which might depend on what specific use case I'm looking for. So if I work in an organization, multiple people will be using this model for trading. It's going to require probably a completely different level of documentation compared to a situation where I'm building this model for myself. But in any case, it's good to make sure that something is put to paper or digital paper about the model. And then I would take this model, the saved model, and this will be put into production. So let's say every day the model would run and would calculate the interest rate for tomorrow, thus allowing me to build my position or decrease it, depending on the forecast. So this is a simplified, stylized example of how this workflow is done recently. Of course, we just glimpsed through the workflow, and later in this presentation, I'll be sharing some examples of how this workflow would actually be, but using Gingado tools, and I hope I can showcase this as being an improvement to the current workflow. Okay, so data augmentation. Before I go into the actual concept, so what is data augmentation after all? So this term is actually used a lot in particular in machine learning fields related to computer vision. So where machine learning reads images and videos. And data augmentation essentially means, for example, suppose I'm building a model to classify bees from wasps, right? So I have to look at a lot of bee pictures, a lot of wasp pictures. But one way to give more data to this model is that I can have some method to augment the data by taking some of the pictures and flipping them over, turning them around, changing the angle just a bit, bumping the picture. They're all bees and wasps pictures. So this should help the model see them and learn different angles and different ways to identify them from each other. But this currently does not exist in economics and finance. So I just took the concept to mean that data augmentation is when you have your data set that you already built of your target variables and your independent variables, and you want to add more data on top of it, but in a way that is consistent to your data set. So for example, suppose you have a time series or a panel data, and So for each point in time, if you add more data, you just don't want to add the whole history for each point in time, or you don't want to add very recent data if your data set is about past periods. So you want to make sure that they line up very well. Otherwise, you're going to have problems where your model is training looking at future data, and this will lead your model to perform very well when you're testing it, but very poorly when you're actually deploying it. So it needs to be compatible. So how does Gingado does data augmentation? It builds on top of this protocol, so the statistical and data and metadata exchange, the SDMX for short. So it's a protocol that is really impressive, actually. It works both for, I'm sure many of you are familiar, if not all, but SDMX as a protocol, it supports the production of statistics, but also the use of statistics by offering an interface that is consistent, that is cross-domain, so and also in a way that allows actually even the act of pulling data from sources, which are typically official sources, in a consistent way. So that is incredibly helpful now for this data augmentation here. So what Gingado does is it offers users some convenience to access data programmatically, building on top of this SDMX. And then what happens is that once you do this, you ensure that all the concepts are aligned and that the data is relevant for your data set with respect to being the same dates and the exact sources that you defined, the frequency, etc. But also another thing you can do is that suppose any transformation done to this augmented data set will now be consistent because it has been done programmatically, but in a neat way, in an easy to use and maintain way. And this is also important not only when you're testing your data and you're trying to make the changes and see what model could be the best, but also when the model is actually in production, because then Gingado ensures that, let's say, suppose that I took that FX prediction model and I pass it on to my traders in my organization, and then what they're going to do is that they're going to need SDMX to pull in data every day to predict the coming days for an exchange. So this is also helped by Gingado. And not to mention that another factor is that by doing this, and in particular through SDMX, we can ensure that the data is pulled from official sources that are reliable. They are, in addition to being reliable, of course, they're the ones that produce the statistics, but also they are well-renowned institutions. They you know that those data series, they are gonna keep on coming through future, and if not, there's gonna be some form of official communication. There are people that are accountable, so you can actually even talk to them and get to know better if you have some questions of the statistics. So SDMX supports getting data from official sources. And before I go to that slide, let me just take Bruno's question here. So he asks, he's in the chat, asking if the library also includes a way of pulling data from various other sources, like and crossing them. So for example, like SE, so the U.S. Securities and Exchange Commission's EDGAR, the Brazilian Stock Exchange B3, Federal Reserve Bank, and Central Bank of Brazil. Yeah, at the moment, Bruno, Gingado is only using SDMX, but it offers a possibility of it's straightforward to build functions that will be compatible with Gingado and with all the other libraries that Gingado is built on top of, and also pulling data in a way that is consistent. So it's just a matter of really having the time to develop all these other augmenters. Those are still in the making, but yes, it's a very good point that you mentioned, and of course they would be incredibly helpful to further increase this use of data. Yeah, so I've already mentioned about SDMX, so I'll not be going into detail there unless there's any other question about this topic. So let me just give you an example how this works in practice. So suppose you have a data set and in Python. So by the way, Gingado is built in Python. Suppose I have a data set, and typically data set in Python, people tend to call it DF for data frame. So once you have a data frame, you import from Gingado's module called Augmentation. There's already this object called Augment SDMX. And what you do, you can name the sources, and then you can fit to your data. Fit transform, what it does is that the fit part will read your data and will know the frequency of the time series, if it's a daily, quarterly, weekly, whatever frequency your data set has. Gingado will know that. And the transform part is that it will take your data, it will download data from all the other sources that you mentioned, and you can also pick specific data flows from these sources, and it will add on top of your data, and it will give it back to you, and now it's called augmented DF in this example. The only problem is that if you're too greedy and you want data from all of the sources, you're guaranteed to need to go make a coffee, because it will be a little process, but just because of the sheer amount of data and the way that it is downloaded and parsed by the underlying library, not by Gingado itself. Okay, so is there any question about the data augmentation? Okay, then if not, I'll be moving to the automatic benchmark part. So the idea here is that when your machine learning has a lot of, there's no analytical response to kind of what is the best model. No one has done this yet. So in practice, machine learning ends up being really a sequence of trial and errors, where the person doing the model, they pick from a wide variety of possible algorithms. For each use case, you have just really a huge variety of models that you could deploy. And even for each model, you have typically more than one parameter that you can tweak and to see how the model fits your data. So what this creates in practice is a space where the space of possible models, and within each model, the possible parameters is overwhelming for any person. And so when you're starting from white canvas approach, really get going from the model and knowing whether or not you are, from all these possible combinations of models and parameters, whether you are, let's say, in the bottom half in terms of performance or the upper half, it's complicated. So having a benchmark will be incredibly helpful there, especially because we don't have, like, for example, in computer vision or many other machine learning tasks that are more traditional. By this, I mean 10 years of considerable work. Well, we don't have so many benchmarks and like public data sets where many people build machine learning models and publish their results. So people do this for other fields, but in economics, I'm not aware of any. So it's hard to have an intuition on whether or not the model that you just created, if it's a good model or a good enough model, or really a model that you might as well discard it. In addition to this, having an automatic benchmark, I believe, it offers a little convenience, because from all of this potential selection of models and parameters, it could be overwhelming, and even perhaps even put some people off away from looking into machine learning models if their use case really is supposed to use machine learning. Then having a benchmark model that, if it performs reasonably well, even if it's not the most optimized model that there is for that case, if it has a reasonable performance, then you already have a fallback case in case nothing that you do performs better than this benchmark. And then you know that, well, at least you tried, but you have a model that you can deploy, and you know that you won't be a complete shame if you apply that model. It might actually be a well-performing model for that particular case. And at the same time, each particular use case that people have, they have a different requirement for what a benchmark is. So not only in terms of tasks, if you're trying to accomplish a classification, a regression, etc., but also the particular level of importance that you give to model performance. For example, if you're working in an institution and you're really trying to screen all applicants, you want to make sure that whatever model that you have, even if it doesn't perform extremely well, that it's fair in terms of not having bias against people from any specific group. So people might have different requirements for what a good benchmark is. So the ability to build a customized benchmark while remaining fully compatible with all the other code is important as well. Before I advance, let me take Raf's question here. So he asked, can you specify particular variables when you augment, or is it all variables or none? That's a very good question. Let me go back here to this slide. So you can specify the source. You can ask for all sources if you have a lot of time. You can also identify specific sources that you want data from, and for each source, you can look at their specific data flows that they might have. So data flows is a specific concept in the SDMX world, which means essentially sort of a collection of related variables. So, for example, the BIS has a data flow for a daily series of central bank interest rates. So suppose I'm interested in that, I can go and just say augment SDMX, BIS, and then the name of the particular data flow, if I know what that is. You can usually check that out in institutions' websites. But yes, so bottom line, and also you can even have I'm showing this later today, and one neat feature of building everything compatible as part of a single library and not a collection of different libraries is that you can actually go back here and say, well, Gingado, please augment my data with those sources and data flows, but then you test against the model, and you can test whether or not adding this data actually improves your model, and if it doesn't, you don't add it, you just discard it. So you don't necessarily need to keep all the data after you retain it. What's important is that whatever the outcome, if you're retaining data set or removing a few, the important thing is that Gingado will help take your model in whatever data augmentation format that it has and make sure that when you add new data, let's say tomorrow I'm trying to forecast interest rates, it's going to augment the same way that it did when it was first created and trained, so that it's always compatible. Welcome. Okay, so here, now moving on to the next slide. One thing that I like to point out is that there's no one best benchmark that really one benchmark to rule them all. Unfortunately, that does not exist, but there's still some ways in which we can overcome this by using some algorithms that they offer reasonably good performance. They offer transparency, and they also train at a reasonable speed. Yeah, before I move, this is a quick one and a good question as well. So G. Charles asks if Gingado is available to install in Python. Yes and no. The no part is not yet. I have a slide where I show this, but the planned launch is tomorrow evening. And from tomorrow evening, yes, we will be able to install in Python with one line of code. And I'll show you how. But yeah, so back to the benchmark. There exist some techniques that allow us to have at least a fallback option for the vast majority of use cases. Gingado, the way I've implemented this is that it offers a generic GGD benchmark object. So this object, GGD benchmark, is actually just a boilerplate for a benchmark object that is compatible with Gingado, but also with other libraries that Gingado uses, like scikit-learn. And in addition to having this model, which you can use to build your own benchmark if you want, Gingado also offers two benchmark models, actually. So they're regression forests with one for classification tasks and another one for regression tasks. So that comes off the shelf. Once you install Gingado and you have your data set, with just one line extra, you can already have a well-performant machine learning model. Again, that might not be the best. Probably it's not the best that you can achieve, but it's a good starting point and a good fallback option. And the way that it's done is that, of course, tweaking the parameter is incredibly important because every use case is different. And I'm sure every one of you is already thinking of potential use case, and they're all different from one another. So the way that Gingado achieves this is by combining the power and flexibility of regression forests, which are renowned for being this Swiss knife algorithm, with grid search, meaning that when you ask Gingado to build an automatic benchmark model, it will search all of the not all, but yeah, from a space of parameters, it was going to search your data and which one performs best, it will retain as the benchmark. So the way that it works is that it has this benchmark object. It includes a data split for your, meaning that how you're going to make sure that when you're testing your grid search for hyperparameter tuning to see what the best format for the regression forest is, you're looking at the in the data split that is comparable with your data. It depends if it's a time series, for example, etc., or a cross section. Then it has an estimator, a pipeline, or just a simple estimator, which is essentially what do you do with your data from the moment you pass it to Gingado up until the moment you're actually handing the data over to the algorithm. For example, you might have some step with data augmentation. You might have some step with, you want to include some principal component analysis. So there's all sorts of different analyses you can do. And then, of course, you have the parameter search part that I just mentioned, where you take this algorithm of the random forest and you search across which combination of parameters works best for your own model. And like I said, it's a good fallback option. So in case you don't, or you can't, or you don't want to bother with testing other models, you can just take that benchmark and use it. The reason I chose random forest is that they don't require any extensive level of data transformation. Actually, they're quite robust. You don't even need to scale your data to have a normal distribution. They have a broad application. They're known for many, many years now with widely successful uses, including in tabular data. By tabular, I mean data that is you put in a spreadsheet, not like a picture or video or text. They're relatively fast to train, even with their power, and of course, they have also a built-in measure of which features are more important. So they offer some transparency to users as well. And here, just quoting from the very recent article in Econometrica, those three economists, they studied whether or not some canonical economic data sets spanning macroeconomics, microeconomics, and finance, whether they tend to be more sparse models tend to perform best, meaning models where we have only a few regressors, or if it's best to really consider a variety of different regressors for each of those tasks. And what they found is that the best prediction is that essentially using different sets of regressors and assembling them all, combining them all in the same model tended to perform considerably best compared to just picking a few variables. And one of these ensemble models, of course, is random forests. So I'll be wrapping up in some 8 more minutes, and just like to show you some a bit about the model documentation part. As I mentioned, I believe this is a part that it should be more automated. I mean, we each have our different requirements for documentation. So if I'm just building something for my own purpose, it's a very different requirement compared to, for example, if I am a bank, then I have a bank supervisor coming in the bank and they need to check the model documentation, or just really there are many different needs. And at the same time, some parts of documentation, not all, but some parts could be automated. So things like who's the user making the model? Well, what was the actual algorithm? What were the parameters? So everything about the model, everything about the data, all of this can be read and parsed and automated. So the person doing this does not need to go and read and say, oh, this was a random forest. I mean, we can code things that does this for us. And the thinking is that when we lower the bar for documentation by automating whatever we can automate, we'll leave brain power to make people think about the questions that only a human can think of, like the ethical implications of their model, for example, or any other thing about their model. Where does this model fit in their organization? So those things, no Python script in the world is going to be able to read that and put that in paper or digital paper. And as I mentioned, I believe that offering this possibility, I hope, can contribute at least a bit to making sure that this is more embedded in the process of actually building these machine learning models. Okay, so yeah, I'll be going very quickly here through the documentation. In this case of Gingado, it offers a similar to GGD benchmark, which is let's say a base benchmark that you can use to build your own. Gingado offers a GGD model documentation object that you can use to build your own model documentation object. And then you have also the already comes off the shelf with Gingado, a model card document, which is essentially, so this is based in a piece of research by leading experts in the fields of machine learning ethics. And essentially, this is what a basic model card looks like, yeah, having those considerations. So we have here the image. This is a direct image from the paper. And the idea of Gingado is that whatever it can automate, it will automate and put in there. But you can also see what are the open questions, and then you can go in and edit them too. So this is an example of code, and as you can see, I've also tried to make this as simple as possible. So before I go here to the technicals, just have a question here from Bruno. Is the goal of having such model documentation also to aid companies regarding classification of what a specific project is using? So Bruno, thanks for the question. Yeah, if I understood the question, yes. So the idea of the documentation is to help users document whatever it is they need to document. And if they're in an organization and they have a separate team of model validators, then they can build a custom documenter for them, but in a way that does this consistently. And importantly, if you do this by Gingado, whenever you, for example, you train your benchmark or you compare your benchmark to your candidate models, then it would automatically document it for you. So in a way, it ensures that whatever it is that your model is at now, you can be sure to have a consistent documentation, so it does not become stale. So a bit of the technicals, also addressing a question earlier. So yes, this is a Python package. It is compatible and heavily inspired by scikit-learn. Scikit-learn, for those of you that are not familiar with it, it's a widely used machine learning library. And by that, I mean, including so from everyone, meaning people just starting machine learning, up to some of the largest banks in the world. Like, yeah, if you look at their page, for example, you see testimonials from JP Morgan, BNP Paribas, and not to mention many other institutions, including Spotify and others. So those are organizations that rely on machine learning heavily, and they all use scikit-learn. And not to mention that also a personal note, it's a pleasure to use that library because their interface is consistent, it's elegant, it's simple. So I use that as an inspiration to try and aim for when I was building Gingado. If I achieve that or not is up to you to judge, but what I did achieve was to make it compatible. So at least if you have a running code, the idea is that you can plug Gingado there if there's some part of Gingado that is helpful to your code. I will be pre-releasing tomorrow, which means that as I get feedback from early users and also as I myself use in other cases, the interface, the programming interface might change. The library is extensively tested, but in real life, we only see issues when we put that to use and we have other people using as well in ways we didn't even anticipate. So it's a pre-release. And the good thing about being in Python is that R users, of which I can empathize, I am myself primarily an R user, you can use Gingado as well through the package Reticulate. As Ryan mentioned, this is an open source software. It will be hosted in this link that you see there. Actually, it is hosted, but it's still not public. And the idea of being open source and free to use is that anyone can contribute, be it with letting me know if there are any bugs or anything like this. And also, it's because it's modular. As I said, there's a GGD benchmark, a base class you can use to create your own, and the same for documentation. If there's anyone that you're using, you feel the community could benefit from, you can suggest me to add there. So the slides, they're going to be publicly available. We can run through the workflow, but I think because of time, I would prefer to leave that for a future opportunity. And I will now just share with you that the planned release is tomorrow at 10 p.m. Basel time. So that should be 9 p.m. London time. And I'd like to thank you very much for your questions, for your attention, and also to see if there's any issues you might raise or any questions.
Thanks very much, Doug. Much appreciated. I thought that was a really interesting talk. Look, if anyone has any questions, please feel free to either, again, put them in the chat or use the raise your hand function and we'll call upon you to ask your question. While we haven't received anything just yet, I have a couple of questions I've been actually looking to run by you for a few weeks now. A little bit about the data integration. So most analysts, data scientists, statisticians all have a favorite toy, all have a favorite software. Usually it's the one you learn when you're in your mid-20s that you never learned another one of. But how does integration work within the context of, say, R or Julia or something to that effect, MATLAB? Can you tell us a little bit more about how the framework interacts with other software packages?
Yes, thanks, Ryan. It's a very good question. So Gingado is based in Python, and the beauty of Python is that it's a language, because it's a scripting language. It was made in part also to have wrappings, meaning you can talk from Python with other languages and from other languages with Python. So as I mentioned, R, which is one example, one I use the most. And there's a connection called a package reticulate that you can just plug Python code, including Gingado, but not limited to Gingado, in your R code and just use it as a normal R object. I am not yet as familiar with Julia. I'm actually just starting to code a bit in Julia and get my feet wet. But I also know that, for example, even Stata users, now they have a module called PyStata that you can move data and back and forth between Stata and Python. So for example, if you have a data set that you already have a well-working routine in R or Stata, probably also Julia, then you can, let's say, you don't need to change all your code to Python. You can take the end result of that routine that you already have, and then you pass it on to Python using Gingado, and then you go back to whatever it is that your use case requires. Of course, it's easier when it's just a one language environment, but it also works well with other languages too. And by the way, even for some other kind of cases that at least I myself don't often think when I think of economic and financial use cases. So even if you're building, let's say, a mobile app, both iOS by Apple and Android systems, they accept scikit-learn compatible models as machine learning models in apps. So if anyone has a $1 billion app idea, they can presumably also do that with Gingado as well. I hope that addressed your question.
No, thank you very much. That's that's really interesting. We have another question coming from Bruno relating to whether there are plans to extend the framework to data that's not sort of time series oriented.
Yes, thanks very much, Bruno. Actually, Gingado, to use Gingado, you don't have to have time series. The data augmentation part works with time series because that's essentially, I would say, virtually all of the official data sets that we have, official statistics. If you think about things like ranging from GDP to interest rates, ranging from the annual frequency to daily frequency, pretty much all of them are time series. But you can still use Gingado, for example, for the automatic benchmark and or the model documentation part. If you have a cross-sectional data set, you don't necessarily need to augment. The augmentation part, really is made for time series and mostly economic, financial, social at that. Yeah. Thanks. It's basically a functionality geared towards those use cases. But as I said, cross-section data sets, they work just as well. It just won't be needing data augmentation from official statistical sources. I hope I answered your question.
Okay, thank you, Doug. Okay, so I've received a question via the chat here. It's to do with communicating results with a framework such as this. And so the question goes, well, it could be argued that a number of quote-unquote black boxes have been applied in this context. There's a lot of complex algorithms. Could you perhaps sort of speak to the challenges and the opportunities in this space then?
Yeah, thanks, Ryan, of course. So the black box issue is in fact a really important one because in real life, it's not just the performance that many machine learning algorithms bring to a use case that matter. You need to know that they're reliable over time. You need to know that, for example, if your model has any ethical implications, and I believe most models that you put to production have some form of ethical implication, you also need to look into that. There's a variety of techniques now that are exploring this space, techniques related to explainability, for example, that they try and shed some light into inside the black box. Other techniques, other tools, for example, there's an amazing tool called TensorBoard, which enables you to have your machine learning model and then you compare across. You can essentially do what if calculations. So what if that particular sample, for example, for a loan credit application, if his income was not, say, 100,000 pounds, it was 110, would that person get the loan or not? So there's a lot of different tools people are using now to shed some light in the toolbox. And I believe that over time, as this issue is alleviated by the combination of these tools to increase explainability, greater familiarity and knowledge of machine learning techniques, but also people having in mind and embedded in their thinking process those ethical considerations, I believe this will unlock some potential use cases for machine learning. But I should say also that I don't believe machine learning algorithms, they should just be blindly deployed across all use cases in economics and finance, be it the academic world or the practitioner world. I think it will be, I'll make an analogy with transportation. So you can, for example, some places you can walk, some you can take a bike, some of them you need a car, whereas others you need to take an airplane. So I think just blindly applying machine learning to all potential use cases is like trying to take an airplane to all of the places that you go through your daily life, and that's not helpful, of course. But yeah, I believe most use cases that are indeed related to machine learning, they could be unlocked as people solve this black box issue.
I think that's an excellent analogy. Okay, so there's a question here from G. Charles, which is interesting. This is, so it's concerning the fact that most of the examples you've used here are in the sort of the macroeconomic space, broadly speaking, whereas traditionally, we generally would associate machine learning with high dimensional data, I suppose. So could you perhaps, talk to the interaction of those two ideas?
Yes, thanks, G. Charles. And actually, I'll say they're not incompatible. So just to give an example now from the academic world, central banks and academia, they were working on new types of macroeconomic models called, for example, HANK. HANK is an acronym for Heterogeneous Agent New Keynesian Model. And depending on the route that you go there, those heterogeneous agents, they can be so many of them, that actually the model is just hugely dimensional, and you need to deploy some machine learning techniques to actually train and estimate the model. In another, but a simpler way of seeing this, I think more down to earth in this particular use case, is that if you have your data set and some particular use case, be it in economics or finance, and suppose you're just adding more data, you're going to augment SDX and you ask it to just pull in data from many different sources, from the IMF, BIS, World Bank, you name it. And then when you see your model, it already has you started with 10, 20 columns of data variables, and now you have over 1,000 variables. So it quickly becomes high dimensional when you start augmenting data, even when we restrict to just using those official sources. The good thing, of course, is that it will only remain high dimensional if it really supports your use case, because you can do what I showed. For example, a grid search. You can look at which combination of parameters in your model that includes the algorithm itself, for example, the random forest, but also includes which sources or data flows you're collecting from. So you can also test for that and see what will be the best case. I suspect that in most cases, consistent with the literature I cited, it would be in the sense of adding more data. Perhaps not all the data there is, but yeah, some more data, and those even macroeconomic models will quickly become high dimensional. I hope I addressed your question.
Yeah, thanks, Doug. I'm conscious of the time here, so I think there'll just be one more question. It's a very broad question, hopefully very easy to answer for you, Doug. It's essentially, where to from here? What are your plans? What might be the scope of future work with Gingado? What might it look like over the next few months?
Yeah, thanks very much, Ryan. Yeah, so the next step, of course, is publishing this. This, as I mentioned, it's going to be a pre-release launch. But still, I'll be happy to put it out there and yeah, have people comment to it, spot any bugs or typos, but also put to use and let me know what really works and what doesn't. And what feels good to use. I think that's important as well, to have a flowing workflow and what is more, clumsy. And yeah, so the first thing is that, and then second is really to try and see, following those principles that I mentioned, flexibility, compatibility, and responsibility, what more can we do to support economics and finance use cases using machine learning in a responsible way and following good practices. So whatever those principles and that goal would lead Gingado, with the help of the community, I hope this would be where we would be going.
Thanks, Doug. Oh, well, unfortunately, that actually brings us to the end of the allocated time. That's flown by rather quickly. So thank you very much, Doug. I really appreciate you taking the time to speak to us this afternoon, and thank you to everyone for participating in this session. Please do keep an eye out for upcoming RSS events. There are many interesting topics in the pipeline, and we hope you'll join us again sometime soon. So in the meantime, I want to wish you all a very pleasant evening. Thank you again, and goodbye.
Well, thank you, Ryan. Thank you everyone that participated. Thanks to you again as well. And I have to say, I'm honored, and it was a huge pleasure as well. I really love the questions and engagement, and I look forward to being in touch with all of you.